Hello everybody. My name is Jakub Bartusiak. I'm a front-end developer at BNY Mellon, Poland, and I wanted to talk to you about a project that we've been working on for about last year, basically. A little bit about the company itself. Well, I'm a part of a studio within the company, and the purpose of the studio is to create like a common pool of developers that are available to different businesses that are within the company. And so when there's needs for some, brains, you don't really need to reach out to the market and find contractors. You just have people on hand, and that also brings benefits to the developers working because we have a variety of different projects from different areas, right? Why this topic, actually? So one of the first things I learned when I joined the project was, you and your friends are the third set of developers that we are throwing at this problem. And I said, okay, why? What happened to the previous ones? They quit, I learned. But I can see why this would be disencouraging to people, and it was very disencouraging to me at the very beginning. While there is some explanations, some cookbooks on the internet, and you can find some examples, they were not like totally applicable in our situation. I will try to explain why. And also, this problem seems like something that many of you can encounter at some point, or maybe you've already encountered it. And some food for thought. Let me give you a little bit of background why this problem even came up. So within BNY Mellon, we have this platform for content delivery. And what I mean by that is that the platform provides like a common set of services of different things like infrastructure, right? And the content providers can create what we call plugins, and they can integrate into the platform. The plugin creators are expected to create their applications as Angular applications, but the code that they develop is basically dependency-less, as in the platform is expected to provide all of the dependencies in the runtime. So obviously, this creates some problems, and that's the root of the problem and the whole project. So obviously, you can see that it is a huge monolith, right? It is centrally managed, and it's very tightly coupled, and it's not very flexible when it comes to the teams developing the content for it, right? They need to use a certain set of dependencies and, have no flexibility at all. So no surprise that we wanted to change that, and we wanted to change that in a way that we just turn the solution on its head, in the sense that the platform now the content becomes the platform. And you can understand it in this way that the content is what's really important, right? The platform provides some like convenience features and maybe authentication, whatever. But the content is what's relevant. The content is what makes the money to the businesses, right? So we wanted to change that in a way that would put the highlight onto the content. The platform becomes distributed, so there's a minimal JS React, I think, runtime that can be invited into the content, and it is responsible still for some things. It has some services and binds all the different contents from different teams under the same umbrella. And I wanted to focus especially on one part of that whole thing called platform, right? The dashboard. Dashboard is also a plugin, but it's special in a way that it itself can pull in additional plugins widgets, right? Different teams can create their own widgets and display them on the dashboard. And yeah, over the years there were like a big variety of those widgets already created, and we didn't really want it to throw them all away or tell all the widget creators, you know, we will need you to upgrade your whole like applications each and one of you, right? So the constraint is that we wanted to keep the old code and keep it running. In an ideal world, we didn't really want to change anything about the original widget bundles. And that's because there's a lot of like controls set around the process of deployment and releasing of the code, right? It needs to go through different like approval steps and so on. And yeah, so given this problem and these constraints, how could we solve this problem? So we went through a few different iterations and different things we could try. So firstly, the very naive solution, right? You could go ahead and just keep the old platform somewhere on the side and pull it into the new dashboard, introduce this legacy dashboards concept, and put it there using an iframe, right? So that's antiquated, obviously, but it also has some pluses, right? So for example, you would ensure that all of the widgets that currently work still continue to work, right? Because you're not changing anything about the original runtime. It's also dirt cheap. You wouldn't really need to implement anything special here, just some like our infrastructure things. So yeah, those are pluses, but the minuses are also huge, right? So the platform still would need to be somewhere, would need to exist and be maintained. There's a large runtime overhead because you're essentially running two applications at the same time. And we would also have problems, we would create disconnect, right? So when the user visits a legacy dashboard, they would see this old platform, and when they visit a new dashboard, they would see this new dashboard. We couldn't really add any functionalities to the legacy runtime. So we said that's not good enough. The second thing we tried and considered was upgrading the versions of the original runtime, or maybe even recreating the whole platform using the latest compatible versions. About the platform, it was conceived back when AngularJS was like still a thing, and it was later upgraded to Angular 2+, but it's still in the version pre-Ivy. So the best we could do in this situation without basically re-engineering the whole thing was to use a pre-Ivy set of dependencies. And again, this has some pluses. So the task of the boundaries of this task are well defined, right? You need to create a new application, basically. And well, it's not trivial, but we all know how to create an Angular application. We could add new features to that new dashboard, and the performance should probably be not worse than the original. But we will still be using the legacy technologies. If you think about it, it's not that much different from just adding features to the original runtime. So the next solution, actually there are two solutions under this umbrella, but let's focus on the first one. It came from the idea, what if we could take the original widgets and somehow turn them into web components? So let's consider the pros of this solution. So we would not be constrained by legacy technology. We could easily add new features because we would have this new dashboard application which just has those web components. And we could even add those features without altering the original runtime. But the platform would need to be somehow adjusted. We still would need to provide all of the dependencies that were originally there. And if we decided to put every individual widget into its own web component, you can see here on this slide, like those boxes. Those boxes would be very similar, but would also not be identical. So essentially, like if you wanted to have 10 widgets on a page, you would need to pull in 10 runtimes. So that's also not good enough. The last solution we tried, and the one that we went with from that point, is to go a different route. Instead of packaging every widget into its own web component, we decided to create a web component which can render any of the legacy widgets. So like, turning this again on its head. So it shares the pros of the previous solution, but on top of that, we have only a singular legacy runtime, and there would be no need to really touch the original bundles in any way. No extra steps, no rebuilding, rebundling, whatever. The problems, well, it's the largest engineering overhead by far in all of those solutions. It would also need to be proven viable in a sense that we can create a proof of concept, and then we would need to actually see if this would even work, right? But yeah, we went with the last solution, and we proved that it indeed does work. So there are three parts to it. So the original widget bundles, the widget adapter web component, and a dashboard 2.0 that we've created. The widget themselves, as stated, we don't really do anything about them. We just keep the original bundles that there were. Also, we don't really need to change any like build process or release process, right? Everything stays the same, and they can work both in the old application, the old dashboard, and the new dashboard at the same time. And that's also important because we plan to roll out the application in parts, right? So it's not like a big bang, everything at once. Some people will see it first, and we will gather feedback. So the widget adapter web component that you see here on the slide, this is like a almost standard way of bootstrapping an Angular application, but instead of doing that immediately for the component, we expose a function, and then we can pass some additional properties to this function and bootstrap when it's convenient, in the sense when the application is idling, let's say. This application exposes just a single adapter component via Angular elements. And it has logic regarding rendering and pulling in additional widgets. And this is done using System.js, in part because the original runtime was using that. And we decided also to use this in this context. Once we have the bundle, the widget bundle, we can go ahead and use standard Angular services to compile it and get component factories out of that, and then we're home, right? Okay, and the last part of the solution is the dashboard application. It goes ahead and pulls that adapter into the runtime. It bootstraps it, and from that point on, basically, whenever you want to create a legacy component, you would just need to create the Angular element that is responsible and knows how to handle that, right? Here's a snippet of a code that handles that in our application. So just standard HTML API. What's cool about this is that there's no hard dependency on the adapter code itself. So if we decided to stop using this at some point, because I don't know, maybe some of the widgets or most of the widgets were upgraded or recreated, we can just drop this and stop, deprecate this service, and don't import the runtime anymore. So in that sense, that's a good solution. Uh, but there are some caveats also and some considerations regarding this. So the legacy platform still needs to be in the runtime, right? In one way or the other. In this situation, it is not without its performance cost, but we do need it in some shape or form, right? So there's not a really good way around that. Also, the solution has been tested with a variety of widgets created by different teams within BNY. But it's not yet been tested with all of them. So I basically expect bugs with this. But I've encountered like a plethora of different bugs while developing the adapter. And all of those were not like game breaking, right? They were regarding a mismatch between the original runtime and what the adapter web component provides. And yeah, what about new widgets? We obviously won't go ahead with the previous process for that, and we are not landed yet on how to do this. We would probably end up going the route with module federation in some sort, but that's a discussion on another topic. And finally, I just wanted to mention that, give credit where credit is due. While I was responsible for the adapter, most of it at least, these some people made it possible so that the application is in a state where it's at the moment, right? So huge shout out goes both to Maria and Krzysiek and to Vadim, parts of our team. And here's some corporate disclaimers for you. Thank you very much for listening. And yeah, have a great day.